Hi, and welcome to the Podatorium. I have a 1939 Sentinel farm radio, and I got a little excited with it, and I already started on it. But it is a model 175 Bravo, and I've already got the chassis out, as you can see. It had quite the layer of dust on it, and as you can see, it's got some serious corrosion on the chassis. There was a mouse nest up inside it, and it was all up in front here. But thankfully, the speaker's in good shape. The cabinet looks really nice. As you can see, that it's still dirty up in there. As far as I can tell, the speaker's okay. I hadn't pulled it out yet. And I hadn't cleaned it out yet either. I did clean the dust off of the chassis. And I have been labeling wires. These two, I'm not sure where they went. Hold on. I'll figure it out in just a second. They might be going to the speaker. They are going to the speaker. Anyway, or one of them might be antenna. I can't remember. They're not going to the speaker. I'll figure it out. Anyway, I was more concerned with figuring out where the B plus and A plus lines went to. If you don't know, the B plus came from a battery. It was a B battery that you had to purchase, and they weren't exactly cheap, but they did last quite a while because doesn't use a whole lot of current for the plate voltage. The battery pack had a B and a 1.5 volt, or there was a 1.5 volt that you could attach to. That's where those two other lines went to. They went to the A battery on those Comstock terminals. I remember taking them off. Okay. At any rate, the plug is not salvageable. One of the pins just fell off. And as you can see, it's pretty much it's original. So I've mapped out where the B plus line connects. It connects to the hot side of this switch. It's a double throw switch, which works. I've tested it. And I might go ahead and hook it up and sorry about that. I might go ahead and hook it up and give my new power supply a try. I made this just for farm radios. So so we'll see what happens. I did test the tubes already as well. Two of them weren't labeled, or I couldn't read the label on them. And two of them I could. So I tested them as they, assuming what they were as in the sockets they were located in, and they tested good. So I'm assuming they're the correct tubes. So I wrote on them what they were on the base there, as you might see with my little Sharpie. But they all tested 95 to 100%, which I kind of expected. Farm radios usually did not have a high number of hours because, again, the batteries were somewhat expensive for people that live way out in rural country. So there you go. All right. Well, like I said, all these components look original, so I don't think anything's been changed. And as what I've seen with a lot of farm radios, I've seen several. They don't have a high number of hours on them because the batteries were expensive, and eventually people just stopped buying the batteries and put them in the attic. So, all right. Well, I'm gonna finish cleaning this up a little bit, and I might hook it up and put a little power to it and see what happens. But it has a what attracted me to this, I found it on Facebook, by the way. It has a nice dial, which I have the needle in the over there as well, which is real pretty. Actually, I'll show it to you. So it looks like a little jewel, but yeah. And the plastic lens on the front is in good shape. Sorry about all the movement. And the cabinet is in real nice shape. And it has the original knobs as well. So we'll finish cleaning it up, getting everything labeled, and I might put some power to it and see if it actually has any life in it to start with before I even start with capacitors. So, all right, we'll see what happens. Okay, we have the lid open here, and this is the little regulator circuit I made for 1.5 volts. AC comes into this transformer. It outputs about 3 volts and comes through here, rectifier, filtered, and that's an LM338 regulator, and the output comes right here, and the adjustment is right here. So let's see what we can do here. This side is the high voltage side. So what we have, it comes right in directly through. This is unregulated, by the way. Comes in through a couple of resistors, filters, load resistor, and it comes out to about close to 100 volts unloaded. So that's not on the dim bulb. It's about 100 volts. So let's see what we got. Right now it's set at 100, or excuse me, 100, 1.4. So let's see what happens when we put it under load. It goes to 0.4. So let's see what we can do here. Let me get this on here. And it's not coming up, is it? That's all the way up. That's only half a volt. So something's sucking down my you know what, we need to see what the current is. Let's go back and set this, because it should be regulated. So whoop, it's a little touchy. Let's leave it there for now, and let's rig it up to look at current draw on that filament string. Stand by. Okay, we have the meters on milliamps DC, and yeah, this is this lead here. Let's make sure it doesn't hit anything. My apologies for the mess. This was I just built the power supply the other day, so, or finished building it. So, all right, we're gonna go to we're gonna turn it back on, and we're gonna turn this on, and let's see what kind of current we're drawing. And 80 milliamps, 75, 76. See if it stabilizes. Yeah, I don't know how. I'll have to check the documentation and see what they're supposed to be drawing. Okay, we have the lid open here, and this is the little regulator circuit I made for 1.5 volts. AC comes into this transformer. It outputs about 3 volts and comes through here, rectifier, filtered, and that's an LM338 regulator, and the output comes right here, and the adjustment is right here. So let's see what we can do here. This side is the high voltage side. So what we have, it comes right in directly through. This is unregulated, by the way. Comes in through a couple of resistors, filters, load resistor, and it comes out to about close to 100 volts unloaded. So that's not on the dim bulb. It's about 100 volts. So let's see what we got. Right now it's set at 100, or excuse me, 100, 1.4. So let's see what happens when we put it under load. It goes to 0.4. So let's see what we can do here. Let me get this on here. And it's not coming up, is it? That's all the way up. That's only half a volt. So something's sucking down my you know what, we need to see what the current is. Let's go back and set this, because it should be regulated. So okay, we have the meters on milliamps DC, and yeah, this is this lead here. Let's make sure it doesn't hit anything. My apologies for the mess. This was I just built the power supply the other day, so, or finished building it. So all right, we're gonna go to we're gonna turn it back on, and we're gonna turn this on, and let's see what kind of current we're drawing. And 80 milliamps. 75, 76. See if it stabilizes. Yeah, I don't know how. I'll have to check the documentation and see what they're supposed to be drawing. But they're 1 volt tubes, so we'll have to see, and I might have to reconfigure my power supply. Hopefully I don't. Okay, welcome back. I have a problem with the power supply. It's I just can't get enough current out of it. I'll have to pull it apart and see what I'm doing with the circuit. So anyway, what I do have is this bench supply. I can 1.5 volts is easy, and each tube should be pulling 50 milliamps. So right now I got 193 milliamps, which is close enough to 200 to call it good, and that's at 1.4 volts, and we have our 90 volts going to it, and we have no sound at all. So let me make sure we still have 90 volts. And we do not. Why not? Oh, because I unplugged it. Ha ha ha. Be safe. Okay, now we have 80 volts. Okay, under load. That is an unregulated supply, so that's not surprising. And I am on dim bulb, so that cuts out, that puts in both bulbs, that cuts both bulbs out. Okay, that's on 1 bulb. We don't have any smoke, so do we have any let's see, any filaments? I do not see any filaments at all. Okay, so it's not working. This is the only thing I've changed so far underneath is the 1 electrolytic capacitor, which is on the 1.4 volt line, the filament line. So, no, excuse me, it's on the B minus. Yeah, B minus. And it's backwards, as you'll note, which is kind of strange. And it's in parallel with the ground. I'm guessing that's an RF bleed off. I'm not sure. Get any noise off of it, I don't know. But as you can see, we do have 1.4 volts, and we are drawing 190 milliamps. Hope that's coming out on the video. We're going to go off dim bulb and see what happens. Let's watch the current. Filament current barely changed. Plate voltage, not that much. 83.8. I think that's probably should work at that. But again, still don't see any filaments. So we're going to stop here. And yeah, we're going to cut that off. And we're going to cut that off. And we're going to watch that go down. That's our plate voltage. So, next step, I start ohming out stuff and checking stuff. And we're starting from nothing. So, nowhere to go but up, right? All right. We'll be back. Okay, we're back. And as you can probably see, I did a little work. I found that this capacitor was disconnected from down there. So I went ahead and changed it. And while I was there, this looked ugly here. So I went ahead and changed that. And before I changed that, this resistor was one of those old dog bones. And let me show you what it read. By the way, I did not have a 2 meg resistor. So I have 2 1 meg resistors in series. I didn't want to go with a 2.2 because I would have got it up too high. But let me show you what it was. If I can get these on here with one hand. Come on. Let's do it this way. I'm having a hard time doing this at one hand, but it measures 2.9 and it's supposed to be 2, so it's way over, and I cannot get this. I'm gonna wrestle with this thing. I just did it with one hand before I turned the camera on, just to practice and see if I could do it. And of course, you know, live performance, nothing goes right? Anyway, it measures 2.9 meg, so way over by about 50%. So I went ahead and changed that as well. And while I was at it, the grid line connects here, which goes up to the little cap. And these caps are pretty ugly. If you can see if I can show you here. Get everything out of the way so it'll focus. Yeah, as you can see, they're rusted and ugly, and I don't have any grid caps, but I have an idea that I think is going to work. What I do have, and I'll go ahead and show you now. Sorry about all the camera movement. This is a little fuse holder, and the little ends that fit on the fuse fit perfectly on the grid caps. So I got some 18 gauge stranded copper wire to do that. And as you can see, I can show you that too. And that fits actually kind of snug too. Perfectly on there. So I'm gonna have some nice new grid caps. Anyway, there you go. I'm gonna change more capacitors before I took it up and try it again. I know these papers, these wax paper ones, the wax is heated up and gone from them, so I know they're bad. So the big one I did check on my little reader, and it measures about 3 times what it's supposed to. So yeah, I'm gonna continue on, recap it. Caps are cheap. And this, as simple as this radio is, and there's not that many, and everything's pretty easy to get to, it shouldn't take me too long. So I'm just going to go ahead and do it. And we'll be back. So I really wanted to show y'all what that 2 meg resistor measured. I've had to hook it up this way. I couldn't do it with just one hand. So as you can see... See the colors here. All right, let's see. All right, trying to focus here. The body is brown, which is 2. The end is black, which is 0. So that's 2, 0. And then the dot is green, which is 5. So 2, 0, and 5 more zeros is 2, and 6 zeros is 2 mega ohms. So that's how we read that. So body and dot. But yeah, so 2 meg resistor, and that's what the schematic says as well. So we'll put that on there, and yeah, that's how far it's out. 2 meg is reading 2.977. So that's yeah, that's about 50% out. Just under it. So that's pretty bad. That's pretty far out. I expect all of these resistors, like I said, these yellow ones that are reading, they're yellow, black, green, which yellow is 4, black is 0, and green is 5. So that's 4 meg. Which the schematic does not have, by the way. So they're 4 meg, and this one I have pulled loose on one side. It's measuring 7 point something, so it's way out also. But those resistors are not on the schematic. But I've tracked them down, and let me show you where they're at. This one and this one. Which show 1 meg on the schematic. So which are, looks like that is the AGC line there, and that is isolating that line from ground. That's RF bleed off. So somehow or another during the production run, they changed those out to 4 meg instead of 1. So I guess to isolate it some more and not load the oscillator, or excuse me, the antenna tuning. So anyway, that's my guess. But I'm going to replace them with what's in there. I had some thoughts about this. I'm going to go ahead and replace them with what's in there. And because obviously it worked at some point. I hope it did anyway. So that's what we're going to do. And we'll be back after I change some more stuff here. Okay, we're going to try this overhead shot now. I realize my production quality is not the best, but I'm not doing this for money. So you get what you get. All right, let's see what we got here. I gotta take this out of here and put that resistor in there. And they have, the way they soldered these is they have wrapped them, the leads around the terminals through the hole and wrapped them around, which is never fun to try and take apart. And this is on the bottom of the oscillator, so I don't want to put a whole lot of heat on it. Let's see but we'll see if we can get something going here. And it looks like it might loosen up. Oh yeah, we're gonna get that one. All right, let's we're gonna snip this bit here. I know you can't see, my hand's probably in the way. And we'll heat that up and see if we can pull it out. Come on, there you go. Oh no, it's wrapped. Ah, you son of a gun. Okay. Oh, these are the hardest to get out. I'm gonna wrap them like this. Yeah, I don't know if you can see how it's wrapped around there, but let's see if we can catch the edge here. Actually, might be. Yeah, let's see if we can do it that way. When you're doing heating leads like this, especially if they're on a coil, you know what? I'm not going to do this. You have to be aware of what's soldered on the other end. With those coils, there's hair thin wires. And what I'm going to do is make a loop here, a little hook that I can, yeah, that's what we're going to do. Oh, if you're not careful, you can heat it up to the point where the wire on the other end disconnects, and then you're faced with trying to connect something that's what's the old country saying, finer than a frog hair. And that's in my way here. And that is this is a ground, by the way. So as you can see, that's tied on that terminal right there. This terminal here is riveted to the ground, which I don't like, but I don't have anything to solder that heavy to the chassis, so I have to go with it, and if it doesn't work, I'll have to troubleshoot it later. Alright, so we are gonna use my little lead bender here. I don't know if you can see this here. We're going to take that, and I don't want to bend it in the middle, so that little tool right there is handy. And this is a cheap set of cheap Chinese tools that I got from Amazon. Let's go this way. Okay, so that's in there, and I can take that and feed through that little hook that I made. Ah, and I went the wrong way with the hook. Of course I did. Which means that it opens the wrong way. That's all right. We got it. And all right, there we go. So now I can solder this. Oh, after I put this back in there, if there's room. And doesn't appear to be. Oop. I have to get some there we go. That's good. That's gonna work. We'll bend that just a little bit that way. And yeah, we can solder that now. And since I've already heated up all the solder on these, I should not have to use any additional flux. This solder I'm using has some RA flux in it. We need to reach. Come on. Here we go. Come on. There we go. There we go. All right. When you got a bunch of leads like this, you got to make sure you get heat to every single wire. So what I'm going to do here is make sure each one is bonded. See, that one's not. Okay. So that's why we check them. So I gotta get, actually, what I can do is whoop, where'd you go? Ah, I see you. Try and catch these, and you're not hunting them down later. Alright. I think I can get under there. Again, you can see that the coil over here on the other side is I think we got it that time. Let's see. Yep. Got that. Resistor snug. And that wire snug. So everything's snug. And now I can trim off that end. Another way to do that is, which I use sometimes as well, is a pair of these. I've got a whole selection of these. They are invaluable sometimes. Which they take some coordination using with your left hand. So, alright, so we got that. Resistor is done. I did not have 4 meg resistors. What the schematic is calling for on most of these resistors is 1/3 of a watt. So, that's what that is there. a third of a watt. Let me move that light out of the way. So, this is a 1 watt, and this is a half watt. And as you can see, that's 3, 0, and 5 more zeros is 3 meg, and that is a brown, which is 1. Black is 0, and 5 more zeros. So, and I made 2 of those because we have another one over here. Let me make sure that's on screen. It is. Yeah, one measured 3.97 and the other one measured 3.93. So, which is a lot of these resistors were 20% tolerance unless otherwise specified. So these should be good. I think next we're going to try and do this capacitor. I've already cut it loose from here. As you can see, I've changed this resistor, which was a, let me see what, I think it's 150 ohm. Excuse me, 15K ohm. So we have 1 and, no, what is that? 1, 4, 0, 0, 0. So, no, 1, 5, 0, 0, 0. 15K. Yeah, that's right. So that's what we got there. So, and that's a 1 watt resistor as well. So you can go up in the wattage in the resistors. Can't go down. Yeah, remember that. All right, let's get this this puppy out of here. And this is foil end on that end. Let's see if we can get that undone without tearing it apart. And this one is on the tube socket, so I don't have to be as delicate as I was with the coil in on that other one. So let's get some solder on there. Put a little solder on your tip with some of this old solder before you try and desolder. It helps transfer the heat and get it melted, and it burns through the dust and everything. So yeah, there we go. And always cock your solder sucker first. And that one is wrapped around. I can see it. So let's see if we can pry that loose. Come on. Come on. Oh, you're leaning against the chassis. It's going to suck up all your heat. Come on. And it's not transferring a while. Let's I don't have this on the stand because it was just too small. Well, it was just small, and I'm not really constrained for space, and I'm not really in danger of damaging anything. So otherwise I have a stand just for radios that I have purchased, and it has actually come in very, very handy. It's just sometimes it's not really needed because let's see if we can just get that up in there. There we go. Okay. Okay. Might have it here. Let me move that out of the way. Okay, come on. Come on, heat up. There we go. Let's all right. Can't see it, but the hole is cleaned out there. So, all right, this is supposed to be a 0.5 at 200 volts. Let's see what it measures. This sometimes tells me ESR, but I don't know. But it's fairly accurate with measuring the capacitors. It does not tell me leakage. So it's supposed to be 0.5 micro. So let's see what we got. And we have 9.6 picofarads. 9.6 pico. That's, yeah. That's way under. Let's see, 9.6 pico, that is, that would be 0.0000095 micro. So, yeah, that's out of there. And it's supposed to be good for 200 volts. I doubt it is. I'm not going to, I've got a big tester that I can check leakage, but there's really no point. And I hit my little, I hit the lever. Most annoying thing about this thing is like $10 on Amazon. And this lever sticks on the side. If you hit it, it just turns everything loose. And yeah, so. But it comes in handy if you just want to do a quick check. So, all right. So that is a 0.5 micro. That would be a, I believe it's a 474. No, 473. Where is it? I thought I had one for that. I thought I had all of them out here. I guess I did not. Oh, that's right. I didn't have a 0.5. Yeah, I got a 474. This is what I got to the closest thing I have to it. So this is a 200 volt. Oh, excuse me. It's over here. Yeah, so this is a 400 volt 0.474. So what I'll have to do, it goes from here to here. So I'm going to have to put some leads on this thing. Okay. I'm going to go ahead and pause, and there's no sense in you watching me change every capacitor in here and figure out how to do this, but I'll show you how it looks when I get done. I'll have to put some leads on here to lengthen it, and there's my little lead bender. So this is handy to use to keep you from cracking that epoxy there. So I'm gonna have to get some lead extender because that doesn't quite reach it. So we'll see how we're gonna do that. But I'll be back. So, I'm back. I thought it important to show this. That large capacitor I took out there, that went from here to over here, or actually this way, but yeah. So it went from this terminal here, which is a ground, to this terminal here, which is part of the A plus line. I traced it all out. Which this wire goes right over to here. So they had run it from here to here because of the size of the capacitor. Since I was working with a smaller capacitor, I was able to just connect it to this, from this terminal to this terminal. And I went ahead and put this one in here. Is going to replace this one. And while I'm at it, since I got to desolder that, I'm going to go ahead and replace that resistor as well. It's another one of those 4 megs that is not on the schematic. They have replaced the 1 meg capacitors with 4 megs. And this capacitor doesn't show up on the schematic either. What does show up, let's see if I can show this, flip this around, is this, where are we at here? Let me make sure I can show this. See if I can hold that steady. This 0.1 capacitor here, so they changed this resistor and this resistor, which is part of the AGC line, so I'm assuming they changed this capacitor as well because of the time constant on the AGC. So I'm going to replace this with a 0.0047, and which is this is the 0.005. So yeah, instead of the 0.1. So we'll do that. But I did want to show that this here, where I traced out these, that where it was actually going and what it was doing, made a lot more sense to just go from there to there. That way I don't have these long flying leads. So maybe that'll even improve the radio performance. I don't know. But we shall see, won't we? Thank you. And I'll be back. All right. I'm going to test this out now. Hopefully I got a little better shot. I can't see the other side there. What we got? Yeah, I might. Alright, I'm going to move that just a little bit. There we go. Alright, let's see how that goes. Alright. So I realized I stuck the stuck the light right in the way of the camera last time, so that was my bad. Apologies for that. And oh my goodness. All right, so I have 2 resistors here. This one, it's very hard to see the colors, but I believe it's blue. I think it's a 600 ohm, which would be blue, black, and I can't tell what the dot is. I can't see a dot. Oh, okay, I think it's brown dot. Anyway, schematic says 600 ohms. And it's measuring like 900, I believe. Let's see. I don't know how accurate it is in circuit, but can you see that? Let me get that in the, there we go. All right. 850 or 840, which isn't too far off. Well, yeah, it is. That's a good 30% off. So that's out. I'm gonna change it anyway. And this one is what is this? This one is 30. It's a 3 meg. Yeah, it's another 3 meg, and it is reading 1.4. No, that's not right. Brown is 1, 0, and then 50. That's a 1 meg. Okay. Is that right? No. Yeah, 1 meg, and it's measured 1.4. So it's 40% out. So we're going to change that, and we're going to go ahead and get this capacitor. Goes into the same place that resistor's going. So we'll try to do these one at a time and not cause any smoke generators. If anybody's wondering what this weirdness on the side of the capacitor is, I don't know if you can see that here. That is where the case from an egg case from a cockroach. So apparently this was up in a barn or a shed for an extended period of time. I expect a shed from the amount of dust, or an attic. So anyway, let's get the soldering iron fired up, and we'll see what we can do with it. I'll be back. All right, let's see. We got everything there? I think we do. Alright. Let's see. Okay. Let's get this thing desoldered. I know there's a million videos out there with people soldering, but I figured I'd show you all a little bit. Since I had my face in the middle of the last segment. Alright, let's see here. Hopefully I'm not blocking you there. Alright, let's see here. I'm going to move this wire out of the way a little bit so I don't burn it. Move that out of the way. I put a little bit of solder on there to help transfer the heat, I think I mentioned before. Alright. We can see what's going on now. So, a little, not that one, this one. Oh, they got them wrapped around here, so it makes it a little more difficult. Because I want to get a clean terminal. That's the resistor there. Put the soldering iron behind it. Come on. Alright, there's that. Okay. There we go. Sometimes if you catch the tail of it, even though it's not desoldered, you can roll it back around and it'll break it loose from the solder. And it's doing some, yeah. Alright, so what I'm going to do now, I'm just going to cut it off here. And unless you can just pull it straight out. Maybe. If I can quit shaking. Gotta heat it up a little. Still goopy solder on it. There we go. And let's clean off that terminal. Well, actually, that's a pretty nice little hole there. That's pretty clean, so there we go. Alright. I got this flying lead. So, this is at 600 ohm to ground. Alright, to make a resistor, what I generally do is I go online and there's a calculator I can use. There's actually a number of them out there to calculate a resistance with parallels, and you can add as many resistors as you want to try and get as close as you want. I've gotten pretty elaborate with it sometimes, building an attenuator where you want to get is absolutely close, like within a couple of decimal points, down to like the third decimal point accuracy. Actually picking out resistors that are closest to the value you want, as opposed to just grabbing one at random. Anyway, I'm going to do that and I'll be back. Okay, so what I've got is, I think I got that straight. Let's see. There we go. Alright, what I've got is, the calculator told me that a 4.7K and a 680 would give me 594. So what I've got here is a 680 and a 4.7K. And let's see what they come out. Let's measure it. And then before we solder it, of course. Let's see. Hopefully you can see that. You can. And that comes out to 589. I believe that's within 10%. So that's not bad. We'll call that 590 out of 600. So yeah, we'll call that good, and let's solder that and put it in the radio for a power test. And go from there. Before I do that though, I have a neat little gadget. So I think y'all can see what that is. Let's see how hot it actually is. See if I can alright, so it's hot. Oop, get on there. So 34, 3450, 3500C. So is that right? No. 350C. I'm sorry. Me and my decimal places. 350C is where it's at. That's might be too hot, but okay. It's on. And we got nothing. I don't see any filaments. Although they are hard to see, I did notice with only 1.4 volts. And I don't see anything. I'm not the slightest bit warm. So, not sure what's going on here. It's on dim bulb. So I guess I need to flip it over and see, take some voltage measurements. So I'm going to do that and see what I can find. I may take a break first. So yeah. And just so y'all can see what I got going on here. I'm using the 90 volt side of that power supply. And I got, yeah, my bench supply there, 1.4 volts. And it is drawing 193 milliamps, which is about right, which is what it got yesterday. So yeah, I'm not sure why I don't have anything. So we need to flip it over and take some voltage measurements. So we're going to do that, and I'll get back to you. Okay, found one problem. Output transformer. I don't know if y'all can see this. This is the B plus line. When the switch closes, it goes through the speaker to the plate. Which is kind of strange. Anyway, yeah. So the output is here. And as you can see, nothing. The speaker coil itself, or the secondary, one of the two, is good. I won't know without desoldering it which one I'm reading, or both. Hopefully I'm reading both, but let's see. Well, I got to take it off to see if I can repair it. If it's something like a broken wire or a connection inside, just inside the paper, or what. But it is a magnetic speaker. So it has its own magnet in there, and this is heavy. Which I could use any magnetic speaker. I don't know what the impedance is on this speaker. It doesn't say anywhere. So yeah, L169M. I don't know what that means. 169 ohms. I don't know. 169K. Could be either. But that is one hefty hunk of magnet. And I cannot take that voice coil off of there. So as you can see, and there's a washer stuck to it. Oh. Alright, let's take this transformer off. I did find a transformer that measures good, but it's I have no idea of the impedance. I don't know if it's the correct size. It's a lot of unknowns. This one came out of a junk radio. I measures continuity, but other than that, I can't really tell much about it. So we're gonna take this off and disassemble it first before I try this. See if it's something. See if this is something simple I can fix. If not, I may have to try that other transformer, and we'll go from there. So I don't know if anybody's taken one of these apart before. Make sure this is all on the screen. Alright, so you have to do a little bending to get this off of there. And then once that's off, there's that slid out of there. Usually sometimes they're interlaced one and one. Sometimes they're not. They're in groups like this, which is a smaller one. It doesn't make sense that they did it as easy as possible because it doesn't really matter. Now I'm trying to get these out of there. These are E-shaped. There's a piece going down the center. You can see here. And then there's the pieces on the outside. And the way I'm doing that, or the way I've been trying to do it, is I've been working it from this side. And I'm just tapping. See if you can see this. Gently tapping it. I don't want to bang it with a hammer or anything. And they're coming out slowly. And once you get one loose, or a couple of them loose and out of there, the rest of it will just fall apart. So I will keep working this. And then I'm going to cut this paper off and start unwrapping it and see what the wire looks like underneath. I've got paper and I've got tape to wrap it back up. I am no expert with transformers, so we'll see what happens. So I think we're going to separate the videos here and make two out of it. I've got all the footage shot, but it's the first part is already stretched out an hour. And I haven't even thought about the chassis yet, so, I mean the cabinet. So, we're going to separate it out, and we'll have part 2 published just about the same time, so you can binge them if you want. But we'll have part 1 and 2, or you can take a break, either way. But this is the finished product, so give you a little preview there. And we'll see you for part 2. Thanks.